right. With that, we are live for another episode of Live Code Tuesday. This week, I'm your host, Thorsten, and I have with me the awesome Ralph Squillace from Microsoft, working on all the things open source, Azure, containers, WebAssembly. And I guess a lot of you already know Ralph from a couple of conferences out there. So Ralph and me, we both had the pleasure of presenting at this year's Wasm, one of the WebAssembly conferences that took place for the second time, right? In awesome Barcelona. So Ralph, maybe you want to introduce yourself? Oh, you're still on mute. Still on mute. Can I unmute
There,
you?
I found the button. The button.
Awesome.
I've been trained by another application to not find the button somewhere else. So I am a principal program manager, used to be program manager, and then we changed the names because that's fun. So I'm a product manager at Azure Core Upstream, and that's the part of Azure that does the compute infrastructure for almost everything that you use compute for. So it's VM compute or container compute, or in this case, WebAssembly compute. And that also includes things like we are also involved in the ACR, the OCI registry, and things like this. My role is actually in part to help open source integration projects like Moby, Docker, container usage, and things like that, as well as things like Kubernetes bits and stuff like that. But I spend most of my time doing WebAssembly, which is like the cloud native binary for the future of distributed applications. So that's mostly who I am. I guess I'm also the Microsoft representative for the Bytecode Alliance Foundation, which is a foundation that does a lot of the work on refining WebAssembly specification additions in the W3C, and also things like WebAssembly components, which are really, really important. And we'll talk about a little bit today.
Yes, we will. Before we jump right into our today's topic, which is WebAssembly on Azure with SpinKube, folks, from wherever you join, just let us know. Use the commenting function, and we will also use it for raising your questions, and we will bring them in and hopefully answer them as good as we can, right? So, Ralph, it looks like it's still sunny outside. Where are you?
I am in southern Italy. So this is where I'm based, and so the sun is still out. I went and picked some cherries, and then I did a bunch of work. So
great.
Yep.
That's awesome scenery. I need to grab a virtual background to at least catch up somehow with your scene. Right?
We definitely need a conference down here, no question.
Yes, let's do that at some point. So yeah, today's topic is running WebAssembly workloads in Azure with SpinKube, right? So before we talked about how we structure this Live Code Tuesday, right? Mm-hmm. So first, I think let's have a look at a sample application running in Azure, built with Spin, using all the goodness that Azure provides, so that we can get a feeling of, hey, what can I do with WebAssembly when running on AKS and having more than just a plain Kubernetes, right?
Right.
So let me bring up my screen quickly. So now we should. Oh yeah.
I'm waiting for the magic.
You're waiting for the magic. There's the magic.
Where's the magic?
Okay. So you should now also see my screen, right?
Yep.
Yeah, cool. So let me get rid of this one and zoom in a little bit on that one. So what we've prepared this is like a high level overview, right, of how, let's say, a day-to-day Azure infrastructure could look like, where we want to run a Spin application. So we start from the developer experience, right, with the Spin CLI. And somehow we want to get our application packaged and distributed to our AKS cluster, right? So we decided, obviously, to use Azure Container Registry as the storage, right? To take to package our application, distribute it to there, and then have seamless integration using underlying cloud identities to pull our OCI artifacts. That's how the spin app is distributed from ACR and run it as a first-class citizen on Kubernetes leveraging SpinKube. So from a cloud infrastructure perspective, we created a simple Azure VNet, a virtual network with a couple of subnets. So I just highlighted those subnets which we are interested in right now in this diagram. So we have our Kubernetes nodes being integrated with the nodes subnet. Then we have a pod subnet where all the pods receive or get dynamic IP allocation. And we have a subnet for backend services. And in those backend subnet, we have integrated Azure Cache for Redis and Azure Flexible Server for MySQL by leveraging Azure private endpoints. And obviously, we assign private DNS zones to the VNet so that in the case that our application, which runs inside of AKS, tries to access one of our past service instance, right? So our Cache for Redis instance, the name will be resolved into a private IP address sitting in the subnet backend instead of going all the way through the internet, right? So by having this kind of boundary, we could ensure that at least from a network perspective, no one from outside the VNet is able to interact with our services. And we can do that, obviously, with containers for years, but with Spin, we can also take our WebAssembly workloads, move them into AKS, and leverage the same, mechanisms and ways on connecting with those backend services as we are used to.
Let me jump in there real quick,
Sure.
because the interesting thing for me to sort of make sure that somebody watching this either now or in the future might understand is that what you've got is it's less complex than a very large and very complex app, and that's for demonstration purpose, right? Like we got to start understanding it. But you've also got some of the fundamental principles of security and production level isolation involved here. This is not a wide open cluster. This is not public endpoints to the services and so forth. And that is the kind of thing that needs to be run, that we're running now in production with containers and so forth. But more importantly, as you roll forward, what you're going to see is that you can use WebAssembly and Spin alongside your container infrastructure. That is, there's nothing different about this at all. It's just running a different kind of process, which is really, really cool. And there's one other question, too, that Dean mentioned, asked really quickly if there was a way to deploy the Spin app on AKS using ARM templates or bicep files. And the answer is absolutely. It's just ARM, and it's just Kubernetes using AKS. So all the tools that are available to you there in Azure and AKS will work here. Absolutely.
Yeah, that's great. So yeah, that's basically. So you mentioned that it's not a production grade, but it's somewhere between like a
sort
development.
of on the way.
It's on the way towards becoming at someday. Once it's grown up, it will be a production grade architecture, right? Yeah. I did not went down that rabbit hole creating NSGs to lock down everything right now, but it's definitely possible because we, as you said, we're first-class citizen and we integrate nicely with whatever the cloud platform offers. So let's move on from the architectural diagram into the Azure portal to maybe take a look at some of the counterparts, right? So there are a bunch of things, deployed to this resource group. But obviously, we want to explicitly look into using PaaS services, like, for example, Azure Cache for Redis to act as a transparent cache for our application. And we want to look into Azure Database for MySQL Flexible Server, that's a mouthful, as actual persistence layer, right? So, there are some cheers out to Ralph already from Mohammed in the chat. So hi, Mohammed. So let's jump into Azure Cache for Redis. And the interesting thing that I will highlight over here is this is a regular standard instance of Azure Cache for Redis, because I'm, as a developer, I don't want to have that burden in, managing Redis in an enterprisey way, as it is reliable, resilient, and available. So I'm happy to rent that on a monthly basis. And, that gives me the freedom of just going to the private endpoint section over here and saying, hey, I have disabled public network access for this instance entirely, and all connectivity to that particular Redis instance has to go through the private endpoint. And if we go to that private endpoint, we see it's integrated in the subnet backend, how I called it in my Live Code Tuesdays virtual network. We have the same configured for our MySQL server. So with that, there's only one exception. For the sake of demonstration, we have public network access still enabled, because we want to, explain or demonstrate the entire lifecycle, from building the application, from running it locally, deploying it to AKS, and then once we made the calls to the local running instance, we can turn off public access and run in a more secure manner, right? But again, we have a private endpoint down here for the MySQL server. And if we go to that one, we also see that it's integrated in the same backend subnet as our Azure Cache for Redis instance. With that, let's move to the terminal and let's have a look at our AKS cluster. Let me bump the font size a little bit more.
There you go.
Yeah. So it is, if we take a look at the nodes, for example, we see we have two nodes running here, and we are using latest and greatest Azure Linux on that one. And so this is like, there is a prerequisite that we have a recent version of containerd, right, in order to deploy SpinKube to the Kubernetes cluster. All the details which containerd version is required is written down in spinkube.dev. So with latest AKS, we are good to go, right? So looking at the namespaces gives us a rough understanding of what is already deployed to that particular cluster. So obviously we see spin operator, like the main counterpart of SpinKube, which is like an open source stack, right? If you haven't heard of SpinKube so far, that allows you to run your WebAssembly work on Kubernetes.
Yeah, and it's worth it. Let me jump in. It's worth pointing out that there's a couple of other things that are there as part of SpinKube, right? For example, there's this weird sounding Wasm namespace, and then there's also Cert Manager, which doesn't come by default. And those are really all part of the SpinKube stack, aren't they?
Yeah, that's right. So you mentioned 2 out of 4 components that build SpinKube, right? So we have Wasm, which we use to bring containerd shim for spin to the underlying Kubernetes nodes, meaning that's one of the building blocks of SpinKube. And we use Cert Manager as a dependency I mean, cert managers, I guess one of the most
Super
popular,
common. Yeah.
they're super common things in Kubernetes world, right? To do all certificate management and stuff like that. And
But
on
it's
top
also,
of that,
oh, go
yeah,
ahead.
go ahead. No, go ahead. Go ahead.
Oh, I was going to say that the thing that's interesting about KWASM, and this is important for thinking about a production level system as you think about like getting complex and really using it, is that KWASM is the runtime. It's the runtime. What is it? Runtime manager, runtime installer manager,
Runtime class manager.
runtime class manager. I forgot the name.
Yes.
inside the SpinKube project in the CNC app. And the important part there to realize is that that allows you to do more than just install. So you can install the operator, but if you decide, for example, the recent OTel support in Spin 2.5, I don't believe it's in the operator yet, or it will be today or maybe tomorrow, very, very soon. But like tomorrow, if you wanted to upgrade, the KWASM as the runtime class manager can actually allow you to upgrade your cluster as you see fit and not just as AKS sees fit. And this gives you more agility to dial in your precise dependencies. That's really cool because it gives you a lot of professional flexibility that you need. And of course, it can remove it if you decide that you're going to tear your resources down. But that's KWASM is actually really important for a full production capability cluster as you go forward.
Yeah, that's a great addition to what KWASM is, right? And some of the unique value or added value that KWASM brings to the table as a runtime class manager. How do we want to deal with questions? Because we got a couple of interesting.
Coming up.
Okay, should
Why don't
I
we
just?
Click on Mohammed's container apps question first, so everybody sees it.
Yes.
That one. I'm going to postpone that one because, of course, we'll get to later on in the conversation. Once we built the app, we get it running and so forth. There's a lot of logical questions about what Microsoft's doing, what's Fermion's doing, and what are we doing together, and things like this. So we'll talk a little bit about that when we get there.
Yes.
Then the other question is touching on auth-c, and I think we're going to get to some of that because, of course, we're going to use some authentication. We have to hit this private endpoint. Right. And then the final one, which I can just discuss really quickly, is when we see gRPC supports. You can actually use all of the stuff we're showing right now. You can use with Dapr right now. So, for example, and Dapr is just gRPC interfaces. You can actually do gRPC with WebAssembly. There's nothing with WebAssembly components now. However, if you're thinking of doing native gRPC, as in there's a compilation for your protobuf and all that kind of stuff, right? But that tooling isn't robust yet. You sort of end up doing hand level work. And so what you really probably want to use is Dapr, which does that kind of stuff for you, more or less. But that's the short version. When we get to the, after all this stuff, we'll dive back into it. Seem reasonable?
Yeah,
go for it, Thorsten.
Okay, cool. So we have cert manager, we have KWASM, and we have the spin operator. So the spin operator comes with a set, basically two CRDs. One is the spin app representing a WebAssembly workload that you all can build, right? And can then run on Kubernetes. And there's the spin app executor, which links your app to a runtime config or a runtime class. So with that, we have obviously prepared an app. So let me move over to my editor and guide you through the app briefly. So we've created a simple HTTP API in or using Go. So this is TinyGo, which is then used to compile our Go code down to Wasm32 WASI. And the interesting thing I want to highlight is there is a simple API over here that has two endpoints, one to retrieve items. We will look into that in a second, and a secondary handler for convenience reasons, right? That we can invalidate the cache from outside of the application by simply the API. Request to the /items endpoint, we first look into our cache. Hey cache, do you have all items in cache already? If yes, then we take those items from cache. So we reduce the load on our database running in Azure, right? And on the way out, on the way back to the callee, when producing the HTTP response, we add a custom HTTP response header indicating that those items has been served through the cache. However, if those items are not in cache yet, if it is a cache miss, right, we go all the way down to the MySQL database, load the items, materials, our Go structs there, end up with a list of items, and then we marshal those back to JSON and store them in cache over here in set item in the cache. And finally, construct another HTTP response, this time with our X served from cache header being false because we went all the way down to the database. So looking at the serve from cache, we see exactly the same result or HTTP response building mechanism, but instead we are providing a true, indicating that we did not hit the database. We were able to serve that request by just looking in our cache. The invalidate cache is fairly simple. We call the invalidate cache method. If something goes wrong, like in every case when something goes wrong, we return an HTTP 500 because it's just me. I coded that API. That's if something's wrong, it's on my side. But if everything works well and the cache got invalidated successfully, then we return an HTTP 204, meaning no content there. So before running the app locally, let's have a look at the cache, because this is the interesting thing, right? The overall goal is to use Azure Cache for Redis at some place as a key value store. From the Spin SDK point of view, we always use the key value SDK. So when we will run the app locally in a few seconds, right? And then we will leverage SQLite. So Spin takes care about spawning a SQLite for us, which acts as a key value store. Later, we will reconfigure the app, so we won't do any code change. We'll just add a small piece of configuration file and deploy it to our Kubernetes cluster and leverage Azure Cache for Redis instead as a key value store. So there's just regular Spin SDK key value calls or APIs that we use over here. And finally, for persistence, the same. We are using MySQL over here to query the database, iterate over the rows, scan those items, and construct a list of items.
Pretty straightforward.
Yes. One thing, WebAssembly, as you maybe all know, is executed in a strict sandbox, right? So in order to use resources, no matter which resources, we have to explicitly whitelist or grant our app the permission to use those resources. So obviously, we have to grant access to key value stores by name. This is the default. I just used the default name for the key value store. And in order to allow outbound connectivity, I have to whitelist which origins is this particular component allowed to reach out to. So there's obviously some configuration that has to take place on the level of your Spin app in order to, grant all the permissions to the component.
And this is critical for production capability, because one of the things that we love about WebAssembly is that you want the code executing inside the module cannot assume that it has full control over the operating system in the way that we've written code for as long as we can remember. This is critical. It may seem a little bit constraining that you have to specifically open up and permit an outbound call. But it turns out that this is going to be the thing that over the next 10 years in distributed computing is going to be the thing that prevents the log4j, that prevents the other supply chain attacks that end up extricating information for you. Only the calls that you permit explicitly are the ones that are going to be capable of executing, which is just fantastic. So this is it's interesting that you're explaining this, Thorsten, as like a developer thing. You've got to make sure you set the configuration, but it's really important to appreciate this is a production quality feature that WebAssembly enables for the next 10 years of our distributed work. It's not just a pain in the behind.
Yeah, I can imagine. I can imagine strict sandboxing being one of maybe the most critical feature from you as like a cloud vendor
Yes.
point of view, right? That you can pack way more workloads on the same compute unit without having the fear of individual customers' workloads interferencing each other, right?
Partly, but like that's absolutely true. Don't get me wrong, but there are even stronger and more subtle problems that exist in the world that we experience right now. And everybody knows, if you're in containers or Kubernetes or cloud native generally, everybody's working on how to secure the supply chain, how to make sure things are immutable and so forth. But remember, when we're doing container work, we're almost always talking about code that thinks it can call anything, right? And so the problem with supply chain attacks and stuff like that is that dependent code that we don't know about can make a call to some server in some other place and pass along internal information to that external server. And what you're seeing here is that can't happen from inside a WebAssembly sandbox. So that little bit allowed outbound hosts is something that's amazingly productive and protective against even having supply chain attacks. The vast majority are very simple attacks in the end, and they're about extrication. This cuts it right off. It's fantastic.
Yeah, it's amazing, right? It's amazing to have that fine level of control about capabilities of an app. And I think for all of you folks joining the stream over here, we're talking about running WebAssembly workloads on Azure using SpinKube, and we were just talking about one of the biggest benefits of WebAssembly, which is strict sandboxing and explicit permissions that we have to give to our workloads. And our regular viewer Barney said that's 100% bullseye, and he was also referring to security implications of Wasm. So yeah, that's one of the most prominent values that WebAssembly brings to the table.
Well, actually, and Bunny makes a few more comments on the WebAssembly component model. I'll just jump to the last one. It's not that the component-based development becomes more difficult or anything like that. No, the real problem is that, of course, in the end, a complex application may permit all kinds of outbound calls. It may be any number of surfaces, including, in fact, in the entire set of syscalls from an operating system. That people may do that. And in that sense, you might think of future WebAssembly containers in the sense of an entire environment capability. But the thing about that is, even though those situations will exist, think about the difference here. As the classic Spider-Man cartoon, used to say, with great power comes great responsibility. The real truth here is that if you enable full OS support in the WebAssembly component, which you can do, right? That is essentially like running a privileged container. You're essentially letting the process own the operating system, and that's fine when it's required.
Yeah.
Right. So your Bunny's not wrong in the sense that we still need to be able to train is the wrong word. Or we need our tools and our workflows to constrain to only opt in the way that allowed outbound hosts opt in, to only opt into those things that you want your code to do. And that is the thing that allows other dependencies to try and make an outbound call and fail miserably. That is the level of productive security that we really want.
Yeah, and on top of this, doesn't it depend how deep you go down that rabbit hole? Because at the end, you could in the end you could limit the capabilities in the runtime you're using, right? And say, hey, I want to use like maybe let me bring up this one from Mohammed as well. Maybe I want to use a runtime or configure my runtime in a way that it allows deeper integration with things like confidential compute, where we maybe not just encrypt like at rest. Maybe we encrypt also the actual.
Well, there is a wonderful. If you're interested in this, there's a couple of projects that do TPM level work. That is trusted execution environments, or TEEs. The main one was Enarx, which was early on a Red Hat project, is still out there. Very, very interesting. And that allows you to constrain your execution of WebAssembly to an trusted execution environment. The chip itself, other tenants on the chip do not have access to that computation space, which is amazing. We had one at Deus Labs called Mysticos that did that as well. I don't know what the status of both of those are, but I'm quite sure, because I know that internally to Microsoft, we had internal customers who want to have access to the TPM, for example. So this is absolutely correct. The amount of granularity that which granularity you can choose is wide open. And these are all, instead of being constrictions, they're all choices and opportunities for you to use the features you want and not worry about as nearly as much about the kind of dependencies you were bringing in somewhere up the supply chain and so forth, because they can't do anything other than that little granular API that you gave access to. So it's fantastic. Anyway, we'll keep looking at the questions, but let's get back to the code.
Let's get back to yeah. So I think we looked at a couple of places already in the code. The Spin manifest is obviously interesting as the manifest of the Spin application itself, but I would jump back to the terminal and just do a simple Spin B, also build the app to ensure I did not make any mistake accidentally. And at some point, yes, all good, I can do a spin up. And I don't provide a runtime config right now, although I have one in this environment. But let me quickly double check something. No, export. So let me do this. I have to set an environment variable to reach out to my MySQL, to the MySQL database, which is a spin variable, and then the app uses the application variable provided. If the env var is prefixed with spin variable whatever, then it becomes a variable in the app and will be forwarded to the component if I asked it to do so. So let me do a spin up over here. And as you can see, storing default key value data to local folder.spin SQLite key value DB. So Spin took care of spawning a SQLite database, which acts right now as my key value store or my transparent cache, so to say. Behind the scenes, the call should go to my Azure Flexible Server for MySQL database, which runs in Frankfurt, so Azure, Germany, West Central. All right, let's move to Postman because I think that's easier to visualize. So let's call it to get items. I get back a 200. And if we look at the headers over here, you can see X served from cache is equals to false over there, meaning that my app had to go all the way down to the database, load the items, and for subsequent requests, so me hitting again, we expect a true. So now this value with all the items, let's take a look at that, and you see there's different coffee specialties being returned from the database. But in this case, we only went to the local cache. So I can, again, invalidate this one by sending the delete over there, getting back a 204. If I send read items again, I get back served from cache false again because cache wasn't there. And now it's set again. So we have the local experience. Obviously, I could have executed or hosted the MySQL database using a Docker container on my machine as well. But yeah, bear with me. I found it easier to just hit the switch on my Azure hosted MySQL database. So now let me do one thing in Azure. So we are on the flexible server over here, Azure Database for MySQL, and let's disable this one, public access disabled. This takes roughly a minute to configure, all the networking bits and pieces. But we can move on. We go back to our solution folder over here. And as you can see, I have an az.toml over here. az.toml in this case is just saying, hey, if this app wants to use key value store default, then please use a storage of type Redis. And then I provide the traditional connection string to my Azure Cache for Redis instance. And yes, I'm leaking right now the password, but I should be fine. Or my
we'll turn it off right after this.
Yeah, my credit card will be fine for a couple of minutes.
No, and while you're waiting for this, we'll get back to the auth N auth Z thing. Here, that string essentially functions as auth N auth Z. But as we roll through the feature set, we'll get to the point where we describe how that's going to change in a production quality system. But for now, we're going to use this.
That's right. There's one pitfall that I want to, talk about. So Azure provides those connection strings in a certain format. The underlying Rust crate that is used in the Spin host, on a Spin host level, wants it in the connection string in a URL format, and there is a double S over here for Redis secure, right? So that we use TLS in that case, and provide the port at the end over here, because Azure Cache for Redis has non-TLS communication disabled by default, which is a good thing. And we as developers has to provide proper connection string for that to work as well. So from there, what have I done after that? I used the, so you saw me executing spin build, right? There is also the spin registry push command, which you can use with a build flag, which basically takes the source code, compiles it again, because sometimes, at least I was facing that I forget building the last, to get the last changes I made into my OCI artifact. So with spin registry,
I think with spin, there is also a build switch that allows you to detect file system changes. So you could use both or the other approach too, which is a great thing about spin.
Yeah, you're right. We could. So you think about the spin watch, which
Yeah.
continuously compiles on file changes, and then from a secondary terminal instance, push it to the OCI registry. And now we are talking. That's great.
It's
That's
cool.
great.
But go ahead. This is great practice.
So we have spin registry push, packaged our spin app as an OCI artifact, and sends it up to the Azure Container Registry. What I did to get that working with Azure Container Registry. So there is an admin account, but always disable that thing, right? Azure Container Registry allows you to do something like create tokens and map tokens to scope maps, right? So you can create a token, you provide let's say a name which acts as the username. You point to your container registry instance and you specify which scope map you want to use. There are, I think, 4 predefined scope maps, if I remember correctly. This one is the one that allows you to push and pull all repositories. And creating such a token gives you back a password as well that you can then use with Spin registry login, or with, for example, Docker login if you want to push your containers there as well, right? Don't use the admin account. Either use underlying cloud identities or use a token with a scope map. And you can also roll your own scope maps with wildcards and whatnot. Yeah. All right. So that said, yes, I have already authenticated against this one, and I just invoke that comment, so it builds the app again, and ultimately it will push it up to the registry.
This is fantastic.
And there we are, right? So I then, lazy me, let me copy this one. I can use SpinKube scaffold from the following image reference, and I can provide a C flag or a runtime config flag over here and point to my Azure specific runtime config, right? And by specifying -C, it gives me also, or it takes my runtime config and creates opaque secret, plain old Kubernetes secret of it, that I can deploy together with my spin app CR into my Kubernetes cluster, and the app will automatically use all the configuration settings that I provided as part of my runtime config tom. So there's one additional nit or hint that we did with that particular application. And in the meantime, we're working, or not we, the community is working on the next release of the spin operator, which will take care of that on its own, right? Because in order to do outbound TLS or outbound connections with TLS, we have to provide CA certificates, and this is, so I will publish this one to GitHub, obviously, so that you also, if you want to try it today, you have like a blueprint that you can follow along and get also outbound connectivity with TLS working in SpinKube on Azure.
And the interesting thing here as well is so because if you're familiar with Kubernetes, frequently people use service meshes to do TLS work, right? And the fact is that this is a way of demonstrating how Spin and SpinKube can do it directly as a standalone process, right? Yes. But you can also use Istio or your favorite, or Linkerd, or your favorite service mesh to do the same thing in Kubernetes as a kind of a Kubernetes generic solution and not specific to Spin. So this is just the flexibility and granularity of Spin and also Kubernetes that you're seeing here.
Okay, yeah, that's great. That's great. So I pushed version 09. So let's change this one to be 09 as well. Oops, no. So like this, right? And let's go to the terminal and say, we want to use kubectl. Oops, no. I have an alias for that. I have an alias for that. kubectl apply.
Anybody who doesn't use K is wrong.
There was already a comment a couple of minutes ago about
Yeah,
that.
I saw it. Yeah.
So let me just simply execute that. I expect nothing will change because I pre-deployed the app already, but we'll
Just in
see.
case.
Just in case,
Yep.
configured obviously
Configured.
because
Yep.
because
Because
it picks up the new version.
Yep.
And if we type fast enough, we should see. Oh no, it's already up and running.
No, you're not going to be able to type that fast.
Yeah, because compared to containers, right, our workloads are so small, so tiny, right, that pulling the OCI artifacts is fast, obviously, and instantiating the modules using containerd shim for spin under the covers is also amazingly fast. All right, so we have the app right now running in AKS. I have an application gateway sitting in front of it, but I don't want to see all of you me typing ingress rules. So instead, let me do a simple K port forward to the service that has been created for me, which is called AZ Cache for Redis, port 8080, and forward it to port 80 in the service. There we go. So if I did not make any mistake with my version 09, I can send a request there and I get back a false not served from cache. We look at the body, we get back our JSON. Sending it again, I get back a 200 again. Headers now being true. And the interesting thing is I go to 8080. We will look at the terminal that you can trust me that it's forwarding the call. But let me invalidate 8080 cache. And I get back a 204 and one final call over here. We see it's now not being served via cache. So we expect 4 calls being forwarded to the corresponding service. There are only 2. Why are there only 2?
Uh-oh.
That's interesting. I haven't counted this before. Let me.
We're going to debug. Ladies and gentlemen, we're going to debug.
Yeah, we have debugging champion on stream. So that's interesting. I think I know what I've done. I think I had. No, I don't have. That's interesting. Let me try something. Okay, at least that's working as expected. Let me forward this one. Why is it not printing every forward? Oh, it's printing 2 calls for this one. That's weird. I was expecting it to print handle connection for 8080 for every request.
Exactly.
Let me do it that way. Never trust a UI, right? 8080, 2, 3, 4. Looks better. That looks way more. Okay, so
more
maybe. Okay, that looks better. So I want to try. I want to be confident, right? So let's do 1 call. I get the items from the cache, right? Then let's do a curl. Oh, let me clean this thing and let's do a curl ix delete. And now my port forwarding get terminated. Yeah. Okay, so let me delete this thing. Let me call the get 1 time. Let me call the get 2 times. Expecting 3 calls. There we go.
And there we go. Okay.
So, me not trusting that UI over here resulted in, I hope, enough calls to our cache for Redis to spot it in the monitoring interface. So let's take a look at metrics. And let's scope that down to the last 30 minutes. And let's say we want to cache hits. And let's do a count. We see a couple of, average was good. Some was better. It takes a couple of minutes, right? Sure. Until those metrics find their way through the Azure metrics engine. But there we go. We expect somehow the chart to go up a little bit more.
Yep.
Yeah. So with that, that was what I prepared for that stream. A small yet realistic app,
Yep.
that demonstrates that we can use Spin and WebAssembly to run real world applications in Azure and integrate with surrounding cloud services.
Mm-hmm. And there's a couple of things that I want to go into with this application really quickly, if I can.
Sure.
So,
Sure.
like, notice that how you used ACR. Now, if you think
Yes.
about containers and you're thinking about Kubernetes and you're in this space, you already know that you've got to have an ACR in, like, say, whatever cloud you're in. I'm from Azure, so we're talking about Azure. Great, fantastic. But it really, all clouds, when you do production level stuff, you can have your own registry that has got a trust relationship. He's talking about the scope map, for example, a trust relationship with the cluster, so that the cluster can pull from that and nobody else can, for example. And the interesting thing here is that you see the same infrastructure. There is nothing different about this. And more importantly, you get to dial into, and we were talking about Kubernetes here, but now I'm talking about ACR, which is just as critical for your production level stuff as anything else. ACR, all the features of ACR work with the WebAssembly component as well. So when you did the spin registry push, for example, what you did is you created an artifact using the OCI 1.1 specification in ACR. You can now turn on round the world replication for that artifact, and it will be in some other region where it's needed. And you don't have to do that. You can also do things like enable artifact caching, and we call it artifact sync, where in ACR you can actually create a cache rule, and you can create other registries that cache this module in Azure to other registries. So let's imagine Thorsten, this is simply impossible, but Thorsten is the lead architect of a huge mega corporation, right? And it's his WebAssembly component that he wants to share out throughout the entire world. Many thousands of developers depending on Thorsten's skill and talent, which, as I said, like, this is impossible. But the point is, it could happen. And if it happens, you can use things like Azure Artifact Sync with Thorsten's component to project it automatically into other developers' registries. So there'll be ACR instances for development for this place and development for that place and so forth. And as part of those things, you can run tasks on them, you can fuzz them, scan them, attest them, do all the kinds of things. I think Mohammed was talking about, using policy and OPA rules and so forth to run against those things. You can use all of those tools to do exactly the same thing. Now, there is one little distinction. The tools like Gatekeeper or Cube Warden, things like this, they tend to examine artifacts that they know about, which means containers, right? And so the only thing you have to do to enable that entire tool suite, and when I say you can do it, submit a PR and make it possible, because it's just open source. But it's also the ecosystem can do, and you can imagine Microsoft and Fermion will invest in making sure that that's possible. The interesting thing there is just the addition of the ability to look at the metadata of this artifact format as opposed to a container image, right? A Docker image is all that's needed. And all of a sudden, all those tools just work. They work wherever they are.
Yeah. Yeah,
So
that's great. And
it's really cool. And, the funny thing is we're talking about Kubernetes, but it's the ancillary services, the MySQL, the Redis cache services that you can project around the world and use all the features and the different SKUs of behavior as you see fit. That's where working in production with a cloud like Azure is the thing that makes you explode in power in a way that you can do yourself with Kubernetes anywhere. But it's a lot of investment. And here, the service is ready for you to make use of it. See the little cache thing down on the very bottom left, Thorsten? I'm not sure you pointed to touchy. Click that. Now look at that. You can create a cache rule.
Cache rule.
And here, you can give it a name, say Wasm component or spin component.
Cache
Yeah,
rule.
you could. Yep.
Yep.
And the
Yep.
source would be Docker Hub. You can do drop down. You're going to use
Oh,
not
yeah.
Docker,
Mhm.
but in fact, you should be able to see. Do you see ACR? Not yet. In this particular version, right? The ability to reflect an ACR registry, right, isn't there, but you
Okay.
can. But you'll notice the ones that you can do. You can, like, for example, let's say, Thorsten, you were using Docker Hub. You can
Yeah.
push to Docker Hub, and then you can use authentication or whatever it might be, and then that will be pulled into even. So your cluster is in a private network, right?
Yeah.
Okay. This will work even in a
Gotcha.
private network. So that ACR in a private subnet will use not the internet, and you do not have to open up a firewall pinhole, right? It will use the Azure backbone network to bring the upstream image, that is, in this case, a WebAssembly component, into your private network for you. And it allows you to enable yourself to run fully private clusters.
So yeah, and to extend this one and take this approach one step further, right? You can then configure Azure policy to whitelist only images from your trusted ACR, and there you go.
Boom. That's it.
There you
So
go.
that all of these tools come together, and there's nothing different about WebAssembly components used with Spin as there is from a Docker container. You can run the containers. That's the Spin work we're doing. You can inject a service mesh, like when you do Istio or Dapper or whatever. That's a container running right next to your WebAssembly component. So you don't have to choose. And
No.
Spin makes it easy to do. And I can't wait to see the hotel feature. Can't wait to see it. What else you got?
Right.
We got 2 more minutes, I think.
Oh, you wanted to highlight something else. You said I want to highlight 2 things.
I
That you're done.
did want to highlight a couple of things, but I got
Yeah.
all excited about the ACR right away.
Yeah.
Because
Yeah.
that's just one feature. The same thing's true of the MySQL or any of the databases services or event hubs or whatever it might be. The service as a worldwide service is something that you want to take advantage of, but you want the experience and the beauty of WebAssembly components and Spin. That's really, that combination is the sweet spot. It's the sweet spot for real work. Now, the last thing is the auth-n, auth-z conversation that Mohammed raised in the beginning. Here we use kind of what you would call the traditional connection string approach, right? And the connection string is in a secret in Kubernetes, and that secret can be backed by something like Key Vault or HashiCorp Vault or whatever your secrets projection provider is. But in a real production environment, you're going to use one of your cloud providers' integrated workload identities. And in Azure for AKS, there's something called a workload identity. And that actually can be tapped into one of several ways. One is a CSI secrets provider that you can mount, and your secrets are there, and they're provided for you on the pod basis. So your pod itself has an identity, and that's controlled by what used to be called Azure Active Directory, which is the enterprise-grade Active Directory in the cloud. And I think it's called Entra ID right now.
Entra ID, yeah.
Do not ask me about name changes at Microsoft. I don't get paid for that. Now, the point there is, when we, Thorsten, I was going to beg you to join me again for another live stream in the future, where we can take this application, add a few things, change a few protocols, and move it into real production with a workload identity rather than that. And then maybe, just maybe, we can take Mohammed's challenge to see if we can wire up some Azure policy, which uses Gatekeeper under the covers.
Yeah.
You up for it?
Definitely. That's
okay.
What we're heading for.
You did a whole bunch of work for Spin for this presentation. Next one's on me.
We are still live. Everybody heard that, right?
Damn it.
But I think Yeah, we'll definitely do a second iteration where we, catch up with latest and greatest innovation happening in both container shim for Spin, happening in Spin Operator, happening in Spin itself, and overall in the WebAssembly ecosystem, right? I think there's one or two things I want to highlight, and one was a blog post that got published last week by the VS Code team, because they allow right now extending VS Code by using WebAssembly, and to be more precise, by using WebAssembly components that are based on the WebAssembly component model, which is awesome, right? Because it finally starts, everything ties together, and we can easily, use the same technical logical components in our VS Code extensions as we are able to use them in the Spin app, right? And
That's right.
That's great. So,
and what's really weird there is it's possible at some point in the future that a Spin app actually could be an extension, which would be really cool. But we'll see.
We'll see, yeah. So this one is definitely interesting. And the other one was the one you sent me along.
Oh,
that
yeah.
is
That is
extending.
really something else.
Yeah.
So that one I want to call out to is using the C#.NET experimental SDK from version 8. We're working on version 9 right now that comes out. Public preview was scheduled to come out in November. And that one will be direct AOT to WebAssembly components. So it should be small and it should be fast. But this one's important because down at the bottom, what Rich does in this blog post is compares real .NET code right now, JITted and AOT'd directly, and he takes the same code and compiles it to WebAssembly and JITs that and AOTs that. And it turns out that WebAssembly AOT'd, right, gets very, very close to .NET, the native stuff. That's amazing. And so we're really looking forward to the version 9 of that.
So by saying .NET native, you mean .NET AOT native AOT compiled, right?
Well, yes. So
yes,
it's near. So read the blog, because if I remember it correctly, it's near .NET. It undercuts .NET JITted, but it's not as fast as .NET native AOT. So that's the sliding scale, is where does it really fit? Because the fascinating part of this, the work that we're doing here in the ecosystem, is speed versus portability and versus scaling agility and cold start and so forth. These are all engineering choices that we make.
Yes.
There is no silver bullet in things we build. There's only choices that are better for us right now and in this place. And so to be able to add C# with the abilities of WebAssembly components is going to be really, really cool.
Definitely. I have had lots of conversations already about, when will C# or we finally be able to split out WASI or WebAssembly components, and a lot of people are looking forward to that one. So let me. Okay, so one final thing that I have on my list is we are doing a short survey about Fermion Platform for Kubernetes. So our commercial offering that provides you even more density than you can achieve with open source SpinKube. And it would be great if all of you could participate in that 3-minute questionnaire. So I will send the survey also to the chat. And with that, we have already agreed on doing at least one additional iteration, right? So I will definitely reach out to you right after the stream so that we can take a look at our calendars and lock some dates for that one, because I really enjoyed it, and the feedback from the audience was more than awesome.
It's great stuff. I look forward to it. I hope this was fun, and I'm not going to watch it afterwards because I hate watching myself. But I'm hoping other people do.
Yeah, me as well. I can't watch it again. Well, thanks
Right.
everybody for tuning
Cheers,
in.
everybody.
Thanks, Ralph,
Thanks,
for
Thorsten.
joining. Thank you, and have a nice evening, everybody.